Hello student, you are welcome to this session. So in this session, let us discuss integration by parts. So already up to 7.5, the entire exercise, all example problems we have covered. So in this session, we'll discuss exclusively integration by parts. This is one of the most important types in integral calculus. So let us start our session. And by parts, to understand integral by parts, and we have to understand the derivation of the formula. Integral of u dv is equal to uv minus v du. Then how to get, that is most important. If you differentiate and u and v are two different functions in x. U and v are two different functions in x. So applying product rule, we can differentiate. V into du by dx into v and plus u into dv by dx. Okay. Now, if you integrate each and every term, this implies integral of d by dx of uv, integration with respect to dx, that is dx, integral of v du by dx and with respect to dx, then integral of u dv by dx with respect to dx. Okay, and this implies the LHS is integral of derivative of uv, d of uv, dx cancel, integral of v du, dx cancel, integral of u dv, dx cancel, and integral of derivative of uv, just uv, then we can introduce some integral constant, uv plus v, then integral of v du plus integral of u dv. Then this implies we can have integral of u dv. What is integral of u dv? Integral of u dv is uv minus integral of v dv. So this is a derivation known as integral by parts. First copy this. Based on this formula, we are going to integrate so many problems. And how to identify whether the integrand is suitable for variable separation. The integrand should have two different factors, two different real functions, trigonometric function, exponential function, or exponential function, algebraic function, or algebraic function and trigonometric function, or algebraic function, logarithmic function. Like this, whenever we have the different combination, different types of the product of two different real functions as an integrand, we should try to write in this form u dv. U is taken and first function, entire dv is the second function. From the second function, we need to find dv. From the first function, leave it as it is. So to find u, first function and second function, we can follow one indicator I late. Dear student, whenever we have two different real functions as a product in the integrand, then we can use the word I late. I for inverse function, L logarithmic function, and A algebraic function, and T trigonometric function, and E exponential function. Whenever we have the clearly the integrand as a product of two different real functions, we should get the help of the letters, the words isolate, and which one comes first, there should be selected no first function, the rest of the function, hold the rest of the function dv. By integrating the second function, we can find dv. By integrating second function, we can find dv. The first two functions should be selected according to the alphabet involved in the letters isolate. For example, the function involving inverse and algebraic mean, and u should be taken inverse. Integral of algebraic function is v. Or logarithmic function and trigonometry functions there in the integral mean. The logarithmic function should be taken u, and integral of the second function, trigonometry function, and should be v, or the entire second function is dv. This is a symbol and procedure to integrate any integrand involving product of two different real functions. Let us start our discussion. So first of all, we will discuss few examples from NCERT book. Example 17 of integral calculus. Example 17, integral of x and cos x dx. Dear student, x is algebraic function and cos trigonometry function. This is the order I, L, A, T, E, isolate. So A and T is available. In this order, A comes first and T next. A comes first mean, so this is U. Cos x dx is dv. Cos x dx dv. I equal to integral of x cos x dx. It should be written U. What is U? Algebraic functions comes first in this order. U is taken straight away. Then the cos x dx should be written as a differential, anti-derivative method. So cos x dx is a differential of minus sin x, correct? And the cos x dx, if you differentiate minus sin x, you can get cos x dx, a differential. So the differential of minus sin x is cos x dx. Now within the bracket, any coefficient, real coefficients there mean, we can take it out. Now I equal to negative of x d of sin x. Dear student, for your convenience, and u is taken as x and v is sin x. By parts, the first term u in dv, the second term minus integral of v du minus u in dv x sin x minus integral of v sin x and differential of u, that is differential of x dx. Then I equal to minus x sin x minus or minus plus integral of sin x minus cos x, so minus and cos x with the integral constant. So this is the and final answer, integrated value of the integrand x into cos x. So this integration method is known as by parts. Just make note of it. Integral of u dv is uv minus integral of v du. So this is known as integral by parts. Okay, and copy it. We'll go to next question. Okay. Then next question number 18. Example 18. Integral of log x dx. Dear student, I have told you already. The integrand is a product of two different real functions in, and we should get the help of the word isolate to identify first function. Here only one function. We do not have any direct formula. A differentiation of log x formula is there 1 by x, but integral of log x, and we have to integrate using by parts alone. We do not have direct formula to integrate logarithm function. So now what to do? As it is, the first whatever only one function given, the given function without giving any preference, the given function should be taken u. The dx is the same as dv, v equal to x. Okay. So by parts, it is integration by parts. I equal to first term u in dv. U equal to log x, v equal to x. So x log x minus integral of v is x at du. U equal to log x means du dx by x. Then x log x integral of dx alone. Then x log x minus x with the integral constant. So this is the answer, and copy it. Okay, next question number 19, example problem. Example 19, integral of x e power x dx. Here x and an algebraic e power x exponential. So in the order of isolate, a comes first. So u equal to x and dv equal to e power x dx. That means v equal to x. Here u equal to x, dv equal to e power x dx. Will be written d of e power x. dv e power x dx means dv. This is v. Now how to write I? U dv, d of e power x. Now we can integrate by parts. We can integrate by parts, and uv x e power x minus integral of v e power x a differential of u dx. Then x e power x minus e power x with the integral constant. So this is the integrated value of the integrand x into e power x. We have integrated using by parts with the help of the word isolate. And go through it. We'll go to one more question. Example 20. Example 20, integral of x sine inverse of x divided by root of 1 minus x square dx. Here algebraic function and square root function and sine inverse x. It is inverse trigonometry function, inverse I. And there are three different natures. To avoid three different natures, as we discussed earlier, in order to apply by parts, we need only two different real function in the place of integrand. So we need some initial steps to bring to the product of two functions. So let us apply substitution for sine inverse of x. Why? Look at, there is a connectivity between sine inverse x and root of 1 minus x square. And dx by root of 1 minus x square is a differential of sine inverse of x. So we can go by substitution. Put t equal to sine inverse x, then dt equal to dx by root of 1 minus x square, and x equal to sine t. Now we can restructure the given integrand. I equal to, instead x sine t, instead of sine inverse of x into t, dx by root of 1 minus x square dt. Now look at product of two different functions. Now we are very much comfortable in applying by parts in order to integrate. So t comes under algebraic and sine t under trigonometric. In this order, a comes first. So here u equal to t and dv equal to sine t dt, or d of and minus cos t. D of minus cos t. So how to write this? I equal to integral of t d of minus cos t. The same question we discussed as the first example. We can take it out, the negative sign out. Integral of t d of cos t. Now by parts, minus of u in dv and t and cos t minus integral of and cos t and dt, and this implies I equal to minus of t cos t, or I take minus inside, minus t cos t is minus or minus plus, again integral of cos t minus sin t, minus sin t. And final answer, what is t actually? T equal to sine inverse of x, and t sine inverse of x, so minus sine inverse of x, and cos t root of 1 minus sine square x name, and root of 1 minus x square cos t, minus sin t is x with integral constant. So sin t equal to x and cos t equal to root of 1 minus sine square t. Sine square t is x square, root of 1 minus x square, and t sine inverse negative negative. So this is the final answer. I'm using by parts and copy it. We'll go to the next question. First question, example 21. Integral of e power x into sin x dx. E power x sin x dx. Here e is a second function, sin x dx is the first function. Then u equal to sin x. How to write? In this particular question, you have to apply by parts two times. And here this is a recurrence type of integral. recurrence type of integrand, and there is one standard formula. But at present, we may not discuss the standard formula. Let us learn how to integrate using by parts and this kind of recurrence and function. Because of recurrence function, 2 times we have to apply integral by parts. This is the first time, e power x, and sin x is the first function. E power x dx will be written d of e power x, u dv. Now we are going to expand and by parts, u into v, e power x sin x minus integral of e power x differential of sin x cos x dx. Okay, again repeating. Then e power x sin x and minus integral of how to write this cos x and d of e power x. This is the second time. Okay, let the result be 1. So left side I. These are the end of the first integration by parts. Now this is the beginning of the second stage. Okay, and e power x sin x minus applying by parts uv e power x and cos x minus integral of e power x derivative of cos x minus sin x dx. Correct? Now we can combine e power x and sin x minus cos x minus e power x sin x dx is a question. E power x sin x dx question denoted by I. And then the last term I and left side I. We can combine these two I together. So 2I equal to e power x into sin x minus cos x. Dear student, we are interested in finding I. We need only I equal to, and taking 2 to the right hand side, 1 by 2 and e power x into sin x minus cos x. Because of indefinite integral, at the end of the integration, we are supposed to give a parameter is known as integral and constant. So go through it, and we have applied 2 times integral with parts, and because the nature of the integrand is a recurring function, okay, and copy it. And e power x sin x or e power x cos x and all, we should follow on the same method. Okay. We go to next question. As application of integral of integration by parts, there is one more standard result we have to discuss. Okay, what is this? If you come across integral of f of x and not a product of 2 different functions here, f of x, then its derivative is available. If this of x, the whole combination multiplied by and e power x dx. F of x plus if this of x e power x dx. So if you come across this kind of integral, how to get the integrated value? By parts we can get the answer no easily. And let us write prove that integral of f of x plus f dash of x e power x is equal to f of x into e power x with the integral constant. As we are going to write the first part alone, leaving the differentiation, that is differential of f of x, with the help of my parts. How to get the result? Proof. Let us start with LHS. Integral of f of x plus f dash of x in the e power x dx. Dear student, let us separate LHS. Integral of f of x into e power x and plus integral of f dash of x e power x dx. The dx should be added. Applying integral by parts only for the first one, f of x can be taken first function, the d of e power x, not to disturb this second term, f dash of x d power x dx. Very important. Applying by parts only on the first, u v f of x in the e power x minus v comes out and f of x dx. Okay, what is derivative of f of x? F dash of x dx. Then plus f dash of x e power x dx with the integral constant, because we need to know a repeated term with opposite sign. So they balance each other. Then final answer f of x into e power x with the integral constant, yes, of indefinite integral. So this is a proof of this theorem. This another important fundamental type of integral based on integral by parts. Based on integral by parts, and go through it. We'll do one question and based on this particular theorem. Just copy it. Example 22. Subdivision 1. Integral of e power x into tan inverse x plus 1 by 1 plus x square and dx. This we have to integrate. If you take I equal to integral of tan inverse x plus 1 by 1 plus x square dx e power x dx. This f of x, derivative of f of x is tan inverse x 1 by 1 plus x square. This is of the form f of x plus f dash of x. So we have to separate into two integral, and tan inverse x into e power x and dx and plus and e power x by 1 plus x square dx. As we derived the previous theorem, we should follow the same procedure. And tan inverse is should be taken first function because of inverse d of e power x plus e power x by 1 plus x square dx. Applying by parts, and tan inverse x into e power x minus e power x, differential of tan inverse x dx by 1 plus x square and plus integral of e power x by 1 plus x square with the integral constant. This will come cancel. Then final answer, and tan inverse x into e power x with the integral constant. This is subdivision 1 of the example 22. Go through it. There is one more subdivision we will complete now, and then we'll wind up with the second part of the example 22. The next session we will continue and exercise 7.6, all the problem based on by parts. Okay, and same example 22, subdivision 2, integral of x square plus 1 over x plus 1 the whole square in the e power x. Okay. Now what to do? Then I equal to integral of x square plus 1 by x plus 1 the whole square into e power x. And we have to restructure. We have to restructure x square plus 1 by x plus 1 whole square in the form of f of x and f base of x. The sum of f of x and f base of x. Okay. Here x plus 1 and with x square, if you add and subtract by 1, x square minus 1 will come. The x square minus 1 can be factorized. One of the factor is denominator. So what is our aim? We should write the variable part in term of x plus 1. That adjustment is most important. So x square minus 1 and plus 2. Minus 1 plus 2 is 1. Then x plus 1 the whole square into e power x. Then x minus 1 into x plus 1 plus 2 by x plus 1 the whole square and dx. After that, x plus 1 cancel, x minus 1 by x plus 1 plus 2 by x plus 1 the whole square into e power x dx. Dear student, if we differentiate x minus 1 by and x plus 1 by quotient rule, x plus 1 the whole square, numerator, derivative of x minus 1, 1. So x plus 1 minus of x minus 1, x cancel, 1 minus of minus 1. That is b. What is the formula? X plus a by x plus b. And derivative of this b minus a by x plus b the whole square. Very simple formula. X plus a by x plus b the whole dash mean b minus a by x plus b the whole square. So applying this b minus a, 1 minus or minus 1, 2. The second part is a derivative of first part. So using formula and I equal to straight away we can write x minus 1 by x plus 1 e power x plus c. Since f of x is taken as x minus 1 by x plus 1 and f base of x is 2 over x plus 1 the whole square. This is our justification, or as usual separate into two integral, apply by parts for the first part alone. After cancellation you will be getting the same answer. So dear student, so let us wind up today's session with the example and concept related to integration by parts and another important type, integral of the type e power f of x plus f dash of x into e power x equal to f of x into e power x. So dear student, we will continue the exercise problems of 7.6 in the next session. Thank you, students.